We have this question we need to answer. Here we have a stepwise function, but you see we need to find these variables, the a and b, but given that this function is differentiable for all values of x. So how are we going to do that? Now, if a function is differentiable, we know that it is continuous in all the points. So now it will then be differentiable and it will be continuous at point x equal to 3. So we'll start there. Now if it's continuous at 3, it means that the limit as x approaches 3 from the negative side of fx will be the same as the limit as x approaches 3 from the positive side. And well, if we approach the x from the 3 from the negative side, we are going to work with this one, and then we just place 3 into the x there, and now it's equal to the limit of fx as x approaches 3 from the positive side, and then we're going to work with bx squared plus 4. So b, and we've just placed in 3 in there, and now if we simplify this, you get 6 plus a is equal to 9b plus 4, and then, well, you have a minus 9b, or 9b is equal to, now this is 4, and if you take this one over, it becomes a negative, so it will be negative 2 in total. So it's 4 negative minus 6 is negative 2. Okay, so that's now we have here a equation. Let's call this our first equation. Now at the point x equal to 3, we know it's differentiable. Okay, so that means at point 3 is differentiable. That means that if we work out the function and we differentiate the function, we get this. Well, if you differentiate 2x plus a, then and now you differentiate it in terms of x, you are left only with the 2. This a will fall away because it is not a function of x, so you'll be left with 2 where the x is less than 3. Okay, and if you differentiate, well, it's less and equal or equal to 3. Now let's look at the next one, next piece of this function, and it's bx squared plus 4. Now if you differentiate this, so if you differentiate bx squared plus 4, if you differentiate that, it will become, well, you put the 2 at the front, so it's 2bx, and you subtract 1 from the exponent, so it's 1. This will fall away, so your answer is 2bx. Okay, so it's 2bx where the x is greater than 3. Now also now, because it's differentiable at all points, we know that the limit as x approaches 3 from the negative side of the piecewise differential function is equal to the limit as x approaches 3 from the positive side of the function that was differentiated. Okay, this is a bit confusing. Okay, so now what do we do next? Well, so now we do this. As the 3 approach, or as the x approaches 3 from the negative side of the differentiated function, the value is 2, because this, remember, is where the x is less or equal to 3, so the value is 2. But as the limit approaches 3 from the positive side of the differentiated function, then the value is 2bx, but now we just place the 3 into the x there, so it's 2b3. Okay, so then you have 2 is equal to 6b, because it's 2 times 3. And then you divide it by 6 divided by 6 to get the b on its own, so it's 1 over 3 is equal to b. This is your second equation now. So all we do now is we we put the 1, or this second equation rather, so you say just 2 in 1. Okay, so 2's value, the b, is equal to 1 over 3. So we just substitute that into the first equation, and it's a minus, that's 9, and the b is 1 over 3 equal to negative 2. So then you have a, negative 3 is equal to negative 2, so it's a is equal to negative 2 plus 3, so a is equal to 1. Now you've solved a and b.